Mrs. John, covering lessons 3 as well as lesson 4 on static electricity. So lesson 3 is just doing some problems on electric force, and this was a short lesson because I did this after going over a test with my class, and I also demonstrated to them the cathode ray tube or the electron gun. So here's just a problem which you can take a look at, and that's how I solved that. Now moving on to lesson 4. These are also problems on electric force. We kind of just finished that. And this was the theory. So this was actually done by a person called Millikan. He did this oil drop experiment by suspending a charged oil drop in an electric field. And why did he do that? Is he wanted to find the size of Q, which is the size of the charge on on the electron. So how do you think he did that? So it is possible to hold a charge stationary in electric field, and anything that is stationary will have acting on it balanced forces. So if you have two oppositely charged plates and you have a negative charge suspended between them and it's stationary, the forces acting on it would be the gravity force acting downwards and the electric force acting upwards. So if you adjust the voltage across the plates, you can kind of just find that point where it balances. Now this electric force is given by E is equal to F over Q, or F is equal to EQ. And you know that E is equal to V over D as well. So when the electric force is equal to the gravity force, so here is your electric force and your gravity force is mg, so you can kind of get how do you get Q. So it is mg divided by E. Now that means mg divided by your E is V over D, okay? And so you get Q is mgd over V. Now I don't think this formula is on your formula sheet. You have all these ones, but then you got to put them together to get this one, to find the size of the charge. And here's a question about stationary charge held in an electric field, and this is how I worked that out. And here is one more.